Hey guys, I hope everyone had a great spring break. Since you've been off for a week, I just wanted to review how to factor um, polynomials with 2 terms and 3 terms like these. So whenever you have your your largest exponent is a 2, they're called quadratics. So that's what we're doing. We are factoring quadratics. So just as a review, we want to think of 2 numbers that multiply to give us 20 and add to give us 9. So if you go through all the factors of 20, you'll realize that the numbers are 4 and 5 because 4 times 5 is 20, but 4 plus 5 is 9. So when the leading coefficient is 1, we don't have to do the grouping. We don't have to do the AC method. You can just go straight to 2 binomials. So we're going to split up a squared, and then we know that our 2 numbers are positive 4 and positive 5. So that's the answer. All right, letter B, we want to think of 2 numbers that give us a negative 24. So a product of negative 24, which means our 2 numbers have to have different signs. And then we need a sum of 2, which means the bigger number has to be positive. So going through the factors of 24, we got 6 and negative 4. So 6 times negative 4 is negative 24, and 6 plus negative 4 is positive 2. All right, so you guys try the others and see if you can get the right answers. Why don't you pause the video and then come back. All right, so letter C. So this one's only a binomial, but this is a special situation, a special factor, because if you notice, we have both terms are perfect squares. So when you have 2 perfect squares with a minus sign in between them, this only counts when it's a minus sign, you're going to find the square root of a squared, split it up, find the square root of 64, we get 8 and 8. And then one gets a plus and one gets a minus. So this is the difference of squares. Now, when this is a plus symbol, this would not match that because we would have a middle term if this was a plus symbol. This is only when we have the difference of squares. All right, letter D, our coefficient, our leading coefficient is not a 1. So we're going to use the AC method. We're going to multiply 5 times negative 4. We get negative 20. So we're going to rewrite it. So we get a 2 numbers. We're going to think of 2 numbers that give us a product of negative 20, but add to give us that middle term of negative 1. So we're going to have negative 5 and positive 4. So negative 5 plus negative 4 is negative 1, but negative 5 times positive 4 is negative 20. So we're going to rewrite this. We're going to bring down the first term. We're going to make the second term minus 5a. The third term plus 4a, and then we bring down the the third term minus 4. And when we have 4 terms, we're going to use our grouping strategy. So the greatest common factor of the first binomial is 5a. So when we divide, we get a minus 1. And then we can factor out a positive 4. And once again, we get a minus 1. So then we take those, what's inside the parentheses, there's one of our factors. Our other factor is what's on the outside of the parentheses. And there is our answer. This is letter D. Hopefully you got that. Now, letter E, the first thing I notice is I can divide this whole thing by 4. No, I can't. 4 won't go into 25. So never mind. All right, so we are going to use the AC method. So 25 times 4 is 100. So we need 2 numbers that multiply to give us 100 and add to give us 20. So that would be 10 and 10, I believe, right? So we're going to bring down the first term. We're going to rewrite the second term 10a. We're going to rewrite the third term 10a. And we're going to bring down the fourth term. And then we're going to do our grouping strategy. We can divide both of these numbers by 5a. We get 5 plus 2, 5a plus 2. We can divide both of these numbers by 2. And, whoops, I forgot my A right here. And then I get I get 5A plus 2, 5A plus 2. And then our answer is what's on the outside and what's on the inside. 5A plus 2 times 5A plus 2. That's it. All right. Now let's look at letter E. So basically our final answer was 5A plus 2 squared. So look at this original problem. Do you notice the first and last terms are both perfect squares? So how would I get this middle term? Well, what's the square root of 25? We know that's 5. What's the square root of 4? We know that's 2. So what happens when we multiply 5 times 2? We're going to get 10, obviously, but then every time we do this, if we multiply these two numbers and then double it, we're always going to get that middle term every time. So this is called a perfect square because the first and last terms are squares, trinomial. And so that's what we're going to look at today. We're going to look at the difference of squares and we're going to look at perfect square trinomials. So basically you're going to find the square root of the first term. So the first term, you're going to find the square root of the last term. When you find the square root of both and you multiply by 2, you're going to get the middle term. And that's the pattern we're going to see today, okay? All right, so now this question is, so basically if we end up with either a plus b squared or a minus b times a minus b, that's considered a perfect square trinomial. So the question is this a perfect square trinomial? All right, so what's the square root of 1x squared? The square root of 1 is 1. The square root of x squared is x squared. What is the square root of 16? 4 and 4. And since we end up with basically x plus 4 times x plus 4, we can say that's squared. That goes along with this pattern, which makes this a perfect square trinomial. Find the square root of the first number, square root of the last number, multiply them. 1 times 4 is 4. And then if we double that, we're going to always get that middle term. So yes, number 1 is a perfect square trinomial. All right, let's try this one. What's the square root of 1? 1x is x. What's the square root of 9? That would be 3. So 1 times 3 is 3. And then when we double it, we get 6. Well, the only way to get a middle term of a negative is if both of these terms are negative. So let's see it. If I FOIL it, I get x squared. X times negative 3 is negative 3x. Negative 3x. Negative 3 times negative 3 is 9. So when we combine those two middle terms, we get that one. So yes, the second one is a perfect square trinomial because that is what we got. X minus 3 squared is x squared minus 6x plus 9. All right, what about this one? Is this a perfect square trinomial? Well, what's the square root of 1? 1. What's the square root of 36? 6. So 1 times 6 is 6. And if I double it, do I get 10? No, I do not. I don't get 10, I get 12. So this is not a perfect square trinomial. The first two were yes. The third one is no, that is not a perfect square trinomial. All right, so using the pattern we established up here, what would be the middle term of this one? So remember, it says we're going to multiply the square root of the first term by the square root of the third term, and then we would double it to get the middle term. So the square root of 16 is 4. The square root of 9 is 3. 4 times 3 is 12. So once we double it, we find out that this is 24. Okay? So basically, we would have 4x plus 3 times 4x plus 3, which is the same thing as 4x plus 3 squared. Let's double check, make sure it works. 4x times 4x is 16x squared. 4x times 3 is 12x plus, once again, 12x. That's why that middle term is doubled. And then 3 times 3 is 9. And that's what we started with. And so we know that middle term is 24. Okay. All right. What about if we're missing the last term? Well, normally we would have taken the square root of 9 times the square root of this number, whatever that would be. And then when we get our answer and double it, we would have to get -6. So some number times 2 equals -6. Well, what number times 2 is -6? But it has to be -3, right? So if the square root of 9 is 3, what times 3 is 3? Well, that has to be a 1, right? And the reason it's a -6 is because that's a minus. So basically, we'd have 3x minus 1 squared, right? So let's make sure it works. We want to see if 3x minus 1 times 3x minus 1 equals 9x squared minus 6x plus 1. Okay, so 3x times 3x is 9x squared. Then we have -3x, -3x, and -1 times -1 is +1. Sure enough, that's exactly what we got. Now the last number, this always has to be positive, because whether it's a positive number or a negative number, you're always going to get a positive product when you square a number. Okay, so I hope that was a little confusing, but hopefully you understood. All right. So now if you notice, our leading coefficient is a 2, but it's to the 3rd degree this time. This isn't a quadratic. So when it tells us to factor completely, remember the very first step is to see, is there a number that all 3 terms are divisible by? Well, in this case, the answer is yes. Not only can I divide everything by 2, I can divide everything by x, because each of the terms are attached to at least one x. So 2x to the 3rd, take out 2x, I'm left with x squared, minus 24 divided by 2 is 12, x squared divided by x is x. And then we have half of 72, which is what, 36? I'm pretty sure it's 36. We took out that x. Whoops. 36. All right, we factored out the 2x. Now we're going to ignore that for a few minutes. We're just ignoring it. And then we're going to think of 2 numbers we multiply to get positive 36 and add to get negative 12. Well, that would be -6 and -6, right? That is a perfect square trinomial, because the first term is 1, that's a perfect square. The last term is 6, that's a perfect square. Since this is a minus sign, we know our 2 signs have to be minus. So simplified, I get 2x times x minus 6 squared. So originally we don't have a perfect square trinomial, but when we factored out the 2x, we did. That's exactly what it became. All right, what about this one? Well, we have a perfect square a perfect square, and see this is a positive, we're probably going to get a perfect square trinomial, right? Because the square root of 9x squared is 3x. The square root of 4 is 2. And since that's a positive, it would mean that both of these are positive. I would double check it just to be sure. 3x squared plus 6x plus 6x, which is 12x plus 4. So yes, this is 3x plus 2 squared. That is a perfect square trinomial. All right, is this a perfect square trinomial? Well, not at first, because I see that there's a greatest common factor. The greatest common factor of these three terms is 3x. So when I factor out a 3x from the first term, I end up with x squared minus 4x plus 4x. Now I see the first and last terms are perfect squares. If I find the square root of 1, square root of 4, multiply, 1 times 2, I get 2, and I double it, I'd get 4. So can you think of what the answer would be? X minus 2 squared. That is the final answer once we've factored it. Erase. All right, factor completely. So the first thing we're going to do is say, okay, well, these are both perfect squares, the first and last terms. That's a plus symbol. So let's see if this works. If we find the square root of 9x squared, we get 3x and 3x. Square root of 49 is 7. So if I multiply 3 times 7, I get 21. And if I double it, do I get the middle term? Yes, I do. So this is right, which equals choice C. So that is the answer. So once you recognize them, it's kind of, you can do them a lot faster. All right, now this one says the difference of squares. So I talked about it earlier. So on these types of problems, the difference of squares means that we're going to have two terms. They have to both be perfect squares. Both are perfect squares. And very important, must have minus sign. It's got to be it doesn't say the product of squares, it says the difference of squares, like this one. So to factor this quickly, you find the square root of x, you find the square root of 49, and one gets a plus and one gets a minus. And it always, there's no x here because that middle term always cancels out. For example, x times x is x squared, and then x times negative 7 is negative 7x. Positive 7x minus 49. Those two terms always cancel out and you end up with x squared minus 49. So that's the pattern you'll see when you have the difference of squares. Okay. All right. Are those both perfect squares? Yes. Is there a minus sign between them? Yes. So we found the square root of 4x squared. We find the square root of 91, no, 81, and one's always a plus and one's always a minus, every time. All right, here we have perfect squares, but I see a plus symbol. So let's say we're going to try, okay, well, let's just try it. Let's see what happens. If that's a plus, let's use a plus, see what happens. Well, if I check my answer, x squared, and then I get 4x and 4x. That middle term cannot cancel out. This would be a perfect square trinomial. This is a perfect square trinomial, which is not what that equals. Okay, if there's a plus sign, you will always end up with a second term. There's no such thing as the sum of squares. That's not a thing. All right, do we have two perfect squares? Well, not yet, but don't you agree we could factor out a 2? So if I factor out a 2, I get x squared minus 9. Now, the coefficient is 1. 1's a perfect square, and 9's a perfect square. So I'm going to split up my x squared. I'm going to split up my 9. 1 gets a plus, 1 gets a minus. Uh-oh, it looks like a plus, but it's a minus. And that's my final answer. That's the difference of squares after I factored out a 2. All right, now this problem right here, I have 4 terms. So I'm going to go ahead. First of all, I'll look at all 4 terms. Do they all have a common factor? Nope. So now I'm going to group them into 2 groups of 2. So I can factor out an x squared. So I get 2x plus 1. And here I can factor out a negative 9. And I get 2x plus 1. Good. So one of my factors is 2x plus 1, and my other factor is x squared minus 9. Now, whatever the degree of your polynomial is, that's how many answers you should have. I only have 2 answers, so you got to look at them carefully. And then you go, actually, wait a minute, this is a difference of squares. So I can factor this one more time. I'm going to find the square root of x squared, square root of 9. 1 gets a plus, 1 gets a minus, and then I bring down my 3rd factor. So this is the final answer. All the other ones, I had 2 answers, 2 answers, 2 answers, but this one I need 3 answers because this is a 3rd degree polynomial. All righty, oh, that was it. Okay, you guys, I hope that helps you get started. So you'll be looking at difference of squares this week. Perfect square trinomials, and then Thursday and Friday you got more stuff to do. So we're going to Zoom on Friday, so make sure you join me Friday because I'm sure you'll have some questions. Maybe not. You guys are so bright. I love that. But make sure you reach out to me if you need some help. All right, guys, I'll see you later in the week.